Yes? I'm sorry, there were some people visiting to collect some information, so I had to attend to it. The screen is visible, right?
Yes, sir,
Yes.
it is visible.
Yeah. Let me go to full screen mode. Okay. System is extremely slow. Right, let me record now. Yeah. So I think in the previous class we discussed up to the chassis frame, right? We saw how it is very different from the ladder frame structure that we have for trucks. Now, I mean, the chassis frame has evolved to accommodate a large room for the passengers and to provide for narrow front and to accommodate the wheels and so on, so that the center of gravity can be lowered, right? Um, but we also discussed about two types of vehicle body construction. What are they? One is body on frame, the other one is
Unibody.
unibody structure or integral type. Unibody or integral type. So now moving forward, let me come to the bumper later on. So let's talk about vehicle body. Since we discussed about the chassis frame, now I'd like to discuss about the vehicle body. So vehicle body is a superstructure. If you are considering body on frame structure, there are two separate components. Like one is the chassis frame, another one is the vehicle body. So vehicle body, if you look at it separately, it is the superstructure of the vehicle. So it can be either integral to the frame or it can be bolted to the frame. Bolted, it's not bolted per se, it's welded mostly, right? So the chassis and the body make the complete vehicle. So, all the superstructure, the door or the roof, and the pillars. What are those pillars? A pillar, B pillar, C pillar. You all know what are A pillar, B pillar, and C pillar in a car? How many of you know what is A pillar, B pillar, and C pillar? You don't know, right? A, B, and C pillars. Does anyone know? You can raise your hands if you know. So I'd like to draw. Let's say this is the car. This is the body of the vehicle, let's say. So this is the front and this is rear. So now, this is the windscreen, right? You guys are able to see what I'm drawing, right?
Yes, sir.
Yes, sir.
So that's the windscreen.
Yes, sir.
So, you have something like this. So this is called A pillar. This is B pillar, and this is called C pillar. 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 A, B, and C pillars. So the one that supports the roof of the vehicle, you should know what is A pillar. Sometimes there can be a D pillar for SUVs and so on, or hatchbacks. But usually it is A, B, and C pillars, which supports the what do you call the vehicle superstructure, right? So what are some of the requirements, the functionalities of the vehicle body? It's very clear. It must be lighter, should not be very heavy. It should be light. It must be designed to have uniform stress throughout, and it must have reasonable fatigue life. What is fatigue? What is fatigue?
Sir, it shouldn't fail when it is subjected to repeated cyclic loads.
Repeated cyclic loads. Yeah, it should not fail when subjected to repeated cyclic loads, or it should not fail so early. It should take a long time. It should be able to withstand a large amount of repeated cyclic load. Then it must have a reasonable dimension and space for inside capacity and engine access, right? And should not be complicated and should allow for future modification. Let's say you want to modify the dimensions and you want to add some components to it, add some parts to it. It should allow for those things in the future, right? So these are some of the requirements of a vehicle body. Okay, and we look at the entire structure. There are, you can look at details. The structure, which structure means it has all load carrying elements. The finish means all the unstressed units like the bonnet lid, door. The door also comes under unstressed unit, right? And the equipment includes seat, heating system, doors, etc. So all these things put together, they form the vehicle body. All these things put together form the vehicle body, right? So passenger car generally consists of a floor panel with engine beams, rear sills, front and rear bulkheads, all those things, wheel arches, roof, dash panel, windscreen, front and rear mudguards, radiator grille, rear window. I urge you to go through the different components of the vehicle body. You can find it online. Just study about what the different, every part has a different name. As I said, A pillar, B pillar, C pillar, there is a windscreen, there's a windscreen wiper, there is a bonnet lid, and there are fenders. What do you mean by fenders? Fenders, fender. What's a fender? Fender is like a mudguard. Mudguard you have in two-wheelers, that which comes above your wheels, they are called as fenders. Okay. So like that, there are different components in a vehicle body. Please remember, what is a sill? Sill covers. Have you heard of SILL, sill? Sill is a part which comes immediately below your feet in the door. The bottom of the door is called the sill. Window sill, you all know about window sill, right? What is a window sill? What is a window sill? Window sill means what?
The space below the window,
Exactly.
there's a small lining.
The space below the window, the platform below the window, where you can sit or keep few things, right? That is called window sill. So same way, sill in automobile means the one which is the platform which is below the doors. Those places are called as sills, right? So there are different components like that. You should know the terminology if you want to understand vehicle, automobile in detail. So you should know all these components, right? So what is a dash panel? What's radiator grille? What's wheel arches? Door side frames? All these things you have to know at least the names of different components. So that that you people can look at any diagram of an automobile and try to remember the names of these different units. So in the previous slide, we saw that the vehicle body should be lighter, right? It should be lighter. Why it should be lighter? Why the vehicle body must be lighter?
Improve fuel economy.
Fuel economy is one thing. What's the other? It should be stiff or it should be flexible. What about the stiffness? Okay, it should be light in weight. What about the stiffness? Should it be stiff or it should be the stiffness should be higher or lower? Yeah,
High.
high stiffness. Why? Why it should
I
have
mean, I
high?
don't want the body to deform easily. No, sir.
We don't want the body to deform easily. Hmm. But then there are two things, right? One is the frame, other one is the vehicle body. Which should be stiff? The vehicle body or the frame? When it comparatively, which should have higher stiffness?
Frame.
Huh?
Frame.
The frame should have higher stiffness. Frame should have higher stiffness. So if you look at old vehicles, the older vehicles had vehicle body made of sometimes fabric, you have seen wooden parts, fabric, like canvas and so on. You guys can relate to it, right? Old cars. The roof of them were made with canvas or fabric or wood, right?
Yes, sir.
Yes,
The
sir.
reason was that by making the vehicle body flexible, you are not allowing the torsion to go through the vehicle body. Most of the torsion is taken up by the frame. Most of the torsion, the torque and twisting moments are taken up by the vehicle frame. Because since the vehicle body is flexible, it doesn't, it absorbs, but it doesn't take up all the torsion that is subjected by the vehicle. Most of the torsion is taken up by the vehicle frame. But then, when slowly people started manufacturing the vehicle body with sheet metal, so the stiffness of the vehicle body started increasing because obviously sheet metals have higher stiffness compared to fabric or wood, right? So now then there was a rattling between the vehicle body and the frame because you are trying to combine the vehicle body with the frame. The vehicle body is also having a certain stiffness, the frame is also having a certain stiffness. When you are combining the two, so they start rattling now. There is a competition between which will take the torsion. So, how to solve this? How did people solve this? There was an evolution of vehicle body. So, how do you think people would have solved this problem of the torsion sharing between the vehicle body and the frame? Yeah, yeah, simple. What did they do? Ideas? You are engineers, right? Think about it. No ideas. You are understanding the problem statement that I'm saying, or is it not clear? I'm not getting any response. Is the problem statement clear?
No, sir. Can you
Once,
repeat
can
the
you please repeat,
statements?
sir?
Huh? Clear.
Once, can you repeat the statement, please?
You have a frame, you have a vehicle body. Older vehicles had a flexible body. The reason was that the torsion was taken up by the frame. They had a flexible body, they made the vehicle body with wood and fabric and so on. So most of the torsional forces and bending and torsional moments were taken by the frame. But now to increase the strength of the vehicle body and increase the rigidity of the vehicle body for various reasons, the vehicle body was made using sheet metal. In large batch produced vehicles, slowly with the evolution of technology, we had sheet metal for vehicle body. But sheet metals have higher stiffness compared to wood or fabric. So when you attach a vehicle body made of sheet metal with the chassis frame, so now there is a competition. Both of them have a certain amount of stiffness. So they are like springs in parallel, right? They are like springs in parallel, and they try to take up the torsion, and because of which there is a lot of rattling between the vehicle body and the frame because they are combined. So how do you solve this problem?
Maybe by the aerodynamics of vehicles, sir. I mean,
It's not about aerodynamics of the vehicles. It is relative movement between the chassis and the vehicle body because of the torsion and other forces. How will you solve this? What can you do? Very simple ways. You can do so many things. You can increase the stiffness of the vehicle frame. You further increase the stiffness of the vehicle frame so that it becomes even more stiffer compared to the vehicle body. Or you add what you call flexible mountings between the vehicle body and the frame so that any relative movement is absorbed by the flexible mountings, right? Those things can be done. Or you try to better integrate the vehicle body and the frame by a lot of rivets or bolts or complete welding techniques. So that is how, when people started slowly seeing that uh, a proper combination of the vehicle body and frame needs to be achieved, that is how they ended up with what is called as the integral body or the unibody structure. They felt that, there is no point in having separate vehicle body and the frame. Let us integrate the two. But when the requirements for a separate frame and vehicle body still existed, they made the frame extra rigid so that most of the torsion is just taken up by the vehicle frame only and not by the vehicle body. That's why you see for any body on frame automobiles, the frame will be extremely rigid compared to the vehicle body. Very high rigidity will be there for the vehicle frame. Right? Is that clear?
yes, sir.
So what are some of the design aspects? See, if you look at the vehicle body, most of the vehicles today have reached very high engine standards. To get improvement in the engine is so difficult because now the engines have achieved very high efficiency and so on. And then we have even started moving on to the electric vehicles. So between different companies, the competition is mainly in terms of the vehicle body design, the aesthetic aspects, right? So structural weight of the vehicle body, load carrying capacity, all these things play a greater role. And what is the aerodynamics of the vehicle? All of them play a very important role. So, and also the engine, engine is one important component, but since most of the automobile companies have reached kind of a saturation in terms of the engine performance, their unique features are shown mostly by their vehicle body design aspects, other design aspects, the comfort aspects, the aesthetics, the ergonomics, and so on. So that's why people focus a lot on those additional features, which are all more or less part of the vehicle body, right? So you can see the 50 to 70% of the cost of the vehicle goes into the vehicle body. Engine has engine consumes a huge chunk of the cost, but the remaining 50 to 70% almost goes into the vehicle body and the components associated with the vehicle body. So that is why vehicle body is very, very crucial. So you can have either a non-load carrying type, a semi-integral type, or fully integral type. That's what we discussed. So the non-load carrying type is what we saw in very old vehicles with all the flexible material. Semi-integral type was when the sheet metal bodies came, then when they started riveting them together or bolting them together, that's a semi-integral type. A fully integral type is a unibody where you don't have separate frame and vehicle body. So it's all combined together in one single unit. So I would like to show you some, yeah. So this is, are you guys able to see my screen now? This ME 5551 vehicle body engineering.
Yes,
Yes, sir.
So this course is a master's level course that I teach for MTech Automobile Engineering, but I thought some of this may be useful for you. So you see what you're seeing on the screen now, right? This one, are you able to see this? Sorry.
Yes, sir.
yes, sir.
So this is called as BIW. What is BIW? Body in white. This is the integral or unibody. So they call it as body in white. You should know these terminologies. You know, if you guys are going to be placed in some automobile company, you should know what is body in white. Body in white means the assembly of a frame panel made up of homogeneous materials. It is before you attach any of the superstructure or the what you call the filling elements like the windscreen or the roof or the bonnet cover, the door, the glass, everything. So before any of these things are mounted onto the vehicle, this integral frame is called as body in white. Why it is called body in white? Usually these are sheet metals spot welded together and stressed and joined together. Usually it is painted white in color conventionally. So now they use a silver paint or different kind of paint. Usually it comes in white color. That's why the term has evolved as body in white. But it represents this, whatever you are seeing on the screen, it represents this frame. This is called as body in white. Okay. And yeah, there are 5 different types of load: bending load, torsion load, combined bending and torsion, lateral load, and longitudinal load. So anyway, if you are interested, you can approach me. I will tell you these things separately. Yeah, so this is the ladder frame chassis that I was telling you. The old vehicles had this ladder frame chassis. You can see the difference, right? The longitudinal members are just straight. There are no bends. The front one is not, the front and rear are not arching up, and the center one is not brought lower. And also you can see in the center, it is still narrow. It is not having a wider frame. So this is called as a ladder frame chassis. The old, very old vehicles had this kind of a ladder frame chassis. It's clear, right? Is it visible to you all?
Yes, sir. Yes, sir.
Yeah, this is a typical ladder frame chassis. So we have evolution. So once, slightly here you can see there is an improvement in the chassis, but then body on frame. So this is vehicle body and this is frame. The whole vehicle body is attached to the vehicle frame. So these are like two springs in parallel, and to combine them, you add another flexible mounting in between. Then you get away with the problem of relative movement or competition in the torsional stiffness of these two components. Yeah, so mountings are made flexible. So body mounts with flexible features. So slowly you see the cross member that I was talking about yesterday. So this is the cross member. The cross member is added in a chassis frame to increase the stiffness. If people feel that they have to increase the stiffness of their chassis, they add this cross member. There are some, I don't know, there are some movies exclusively related to automobiles. There was a movie, right? Some Ferrari versus something. How many of you know that? Have you guys heard of that? There was a
Ford
Ford
versus
versus
Ferrari,
Ferrari.
sir.
Ford versus Ferrari. I have not seen that movie. How many of you have seen that? Have some of you seen that?
Yes, sir.
But I think there they mostly concentrate on the engine aspects, right? Do they concentrate on the vehicle body aspects? No. So go back and look at the film. I don't know. They may be talking a lot about the frame, how it is. Of course, if that is a, is that a F1 car or it's a regular other?
Sir, it's a Le Mans car.
It is
Endurance
not.
racing. 24 hours of Le Mans.
It's not F1, right? Is it
No,
F1?
sir. No,
It's
sir,
not
it's
F1.
not F1.
So okay, then F1 cars are extremely different. They have a monocoque structure. Our discussions don't apply to F1 cars, but the other ones, I think whatever we discuss here may be relevant to that Ford versus Ferrari, whatever they are showing. You can see whether they talk about vehicle body there, right? So please look into the details. So this is the cross member, as I said, to increase the stiffness, and the cross-shaped braces. Here the side ones that you see here. These are also to increase the stiffness of the frame. So you can have different members welded to different parts to increase the stiffness. So finally, they thought of integrating the vehicle body with the frame in several different locations. So which ultimately led to what we have as the unibody structure today. So this is pure monocoque, you see. F1 cars use this, aircrafts use this, the pure monocoque structure. There are several different structures. I'm not discussing all those things with you, but maybe a bit too much. But yeah, this is a semi-integral or a bird cage frame, and this one is the fully integral or unibody structure, what we have now. So there is a whole evolution of vehicle body which you can go through. What I'll do is I will upload this slide also in LMS. You can read through this content so that you can understand better aspects of the vehicle body, how it has evolved from body on frame to unibody. We do have body on frame even now, but more or less it is unibody structure. Okay. Yeah, and I wanted to discuss a little bit about aerodynamics. Yeah, this is also from the MTech, but then I felt this is important. How the vehicle body shape has evolved. Yeah. You see, are you able to see the diagram on the
Yes, sir.
screen?
Yes, sir.
Yeah. So usually there are 5 constituent elements of drag. The first one is called as form drag or pressure drag. Then you have skin friction drag. Then you have ex. Let me induced drag, excrescence drag, and internal drag. Yeah. Excrescence drag is, I mean, skin friction drag is due to the surface properties of the automobile. Form drag is due to the shape of the automobile. Induced drag is because a lift is induced, right? When the vehicle is moving, sometimes a lift can be induced. And the horizontal component of the lift is called induced drag. And then excrescence drag is caused by all the additional components like external rear view mirrors, fenders, and the door outer strips, and all those things. Those things, what the drag created, those created due to those things are called as excrescence drag. And there is something called as internal drag because of the air flowing through the vehicle compartment, different compartments of the vehicle. So that is called internal drag. So these 5 different constituents of drag are there in an automobile. But the form drag and skin friction drag are the top two. They are most important to be considered. So you see, when the air flows, let me make this full screen so that Yeah. So you see, when the vehicle is, this is the direction of movement. So it is in this direction the vehicle is moving. So let's say airflow is obviously like this, correct?
Yes, sir.
Now what happens as soon as the air comes into contact with the vehicle in point A?
It
What
diverges.
happens? Yes?
It diverges.
No. Okay, let me draw a vehicle like this. So now what happens? Now what happens? Are you able to see
Sir,
what I've drawn on the top?
applies a resistance force.
Yeah, it's usually it gets stagnant. It immediately experiences stagnation, correct? So you see this diagram here. Are you guys able to see the diagram here? The coefficient of pressure versus the location. This is the location on the vehicle, the x-axis. So at point A, you see the coefficient of pressure is very high because moving air comes to rest in that place, correct? So that's the reason they try to keep the location A as small as possible. That's the reason they don't make the cars like this. They make it pretty narrow. You understand the reason why? Because they don't want air to get stagnant there. Correct?
Yes, sir.
Yeah, then suddenly then the air gets diverted and flows over. So that's why the velocity increases and then the pressure decreases. That's point B. Right? And then when you go to point C, again there is a small stagnation of air due to which the pressure increases. And then if the vehicle body were to be like this, then D point will also be quite higher in pressure. But this is called as what is this called as? Windscreen angle. The windscreen angle is made larger so that air can easily flow over. So due to which the pressure is brought down again, and then the air easily flows over the vehicle body, comes back, and then if you have a large area here, you get a huge wake zone. So that is why even the bottom side is made as narrow as possible. As narrow as possible. But of course, you can't completely, if you want a completely aerodynamically uh, proper automobile, you will lose your own unique vehicle body styling and you know uh, the the uniqueness of your own design. So people play around with the design to ensure that there is minimum drag. At the same time, there is a certain aesthetics to it, right? Many of the cars do not exactly adhere to a complete aerodynamic design. They still go with different designs, but within that, they try to achieve minimum reduction in drag, right? Is that clear?
Yes, sir.
Yes, sir.
Yeah. So, stop this. Okay. So I think with that we have come to the end of the chassis unit, right? So any questions? Any questions? So I think from Monday you guys have mid exam.
Yes, sir.
When is
21st.
automobile exam? Have you got the timetable yet?
Yes, sir.
When is automobile engineering? Maybe I am not seen it yet. When is the automobile exam? Yeah. Anyone? Can you just update me when is automobile
Sir,
exam?
we didn't get the timetable, sir.
You have
Officially.
not, officially you have not got, but unofficially, do you guys know? Or you have just suggested something, is it? Yeah.
So unofficially we suggested for 23rd Feb.
23rd, is it?
Yes, sir.
Okay, so more or less it will be on 23rd. I don't know. If there is a change, accordingly we'll see. So what we will have till chassis, right? So I've completed 5. There are 5 more chapters. We'll take it up after mid-exam. When is the last date for you? When is the last working day for you guys? 26th of April. Yeah. I think it's 26th of April, right? Can someone just confirm that?
Yes, sir. 26th April.
26th April. So we have enough time. But there are very important units coming after this. Very important units, steering system, suspension system, transmission system. All these come after mid-exam. Okay. But anyway, so we will have this 5 units for mid-exam. Is that all right for you guys?
Yes, sir.
You guys have any suggestions? You want to tell me anything about your mid-exam? Yes? No inputs from your side? Okay, so if there are no inputs, that's it for today's class. Thank you guys, you can go. But if somebody wants to stay back and have some discussion, you can stay back. I'll be here for another 5 minutes. Those who want to leave can leave. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.